So today at the end of the lesson, we ended up with a little bit of a practice quiz. We didn't have time to go over it in class, so that is what I'm going to do now. Our practice quiz, we had an object that was being pushed at an angle of 40 degrees. The force was 150 newtons. On a rough surface. So our coefficient of friction equals 0.2. I know a few of you ended up with a different number because you misread. I didn't quite put it on the board correctly. So mu is supposed to be 0.2 instead of 0.002. My bad, I just didn't make it clear enough. So let's draw our force diagram. We have one force in the x. We have force normal, the x direction. We have force normal in the y direction. We also have another force normal going up because it is, and we also have a force gravity going down. Looking at it, because it's a rough surface, we will have a frictional force going backwards. So just to recap, we have a force of gravity going down. We have a force being pushed at an angle, so we broke that into its x and y components. Whoops, there, I actually drew the y component in the wrong spot. This is why I like to go over things a couple times. So then we have to balance out these forces, because we're sliding across the ground, I have a force normal of from the ground. And we also have the force normal in the x from the push and the force of friction in the x. So using this diagram to make our net force equations, I will start with the sum of the forces in the y equals mass times acceleration in the y. Why start in the y? Just because I know we're not accelerating, we're sliding in the x. So it just makes, I think that's a little easier to start in the y. So we have a force normal going up, so that would be positive, minus a force of gravity going down, which makes it negative. And we also a negative force normal from the hand because of the angle at which it is being applied. Equals our mass time. We already decided that acceleration was 0, so it's going to equal 0. So our force normal, if we just subtract gravity and the normal y, we will get force normal equals mg plus force normal sine 40 degrees so we can do the math, plug in our numbers and do the math. We have a 70 kilogram person with 9 times our gravity, which is 9.8, plus our force normal being applied is 150 newtons times the sine of 40. If I put that into the calculator, I should get 782. .4 newtons. Now we have a normal force, and we're looking for acceleration. So we'll switch to the y real quick. The x, define our acceleration. The sum of the forces in the x will equal mass times acceleration in the x. So looking at our diagram, we have a force normal in the force normal in the x direction, which is positive, and a negative force of friction equals mass times acceleration in the x. So we know our force of friction. If we pop over here, force of friction equals mu force normal. If we go back, that'll be in our equation sheet that is on Google Classroom. I can plug that in, and I'll just plug in a couple numbers here. We have our 150 cosine, because it is in the x, we have a cosine, 40 degrees, minus our force of friction, which we saw was mu Fn equals mass times acceleration. So now if we plug in our force normal that we found into here, we're using this force normal because this is the force normal that is being applied by the ground, because the ground is also applying the force of friction. The contact between the ground and the box is causing friction. So that's why we're using this normal force and not this normal force. Equals our mass of 70 kilograms times our acceleration. Now we just have to do math. So now let's all put this into our calculators here. 150 cosine of 40 minus 0.2 times 782.4. That equals negative 41.57 equals 70 times A. I'll divide through by 70. To get acceleration, and that gives me acceleration to equal negative 0.59 meters per second squared. So I hope this clears things up. I know many of you got the right answer or the correct process. Please come to talk to me or Mr. Szymanski if you have any questions on this before the midterm. Other than that, have a good day, and I will see you next time in class.